Hi team, Mr. Vittori again. Okay, question 7. Well, we just, as you know, when you multiply two numbers and the base is the same, what you do to the powers is add them. So in this case, very simple question. You keep the base as 5 and add the powers 4 plus 6 because we got times in them. Okay, so what we end up with is 5 to the power 10. Okay. Reason for this addition, obviously 5 to the power 4 is the same as 5 times 5 times 5 times 5, and then you times in, and 5 to the power 6 means you got 5 times 5 times 5 times 5 times 5. You've got 1, 2, 3, 4, 5, 1 more 6, and altogether you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 5 to the power 10. Similar occasion here, but subtracting. So when we subtracting and the base is the same, we subtract the powers. Sorry, when we dividing and the base is the same, we subtract the powers. Reason being is you could rewrite the division as a fraction and put 7 to the power 5 and 7 to the power 2, which is the same as 7 times 7 times 7 times 7 times 7, 5 times, and 7 squared is 7 times 7. Anything divided by itself is 1, so they cancel. Anything divided by themselves is they cancel. 7 divided by 7 is 1, 7 divided by 7 is 1, and you're left with 3 7s here, so 7 times 7 times 7, which is the same as if we had 7 and did 5, subtract the power 2, that will give us 7 to the power 3, 7 cubed, as we will get here. Okay, so there's the answer for this one. Okay, it's pretty straightforward, that's standard. This is laws. Okay, clear that. Scroll further down, question 8. Okay, when we're writing this as a product, it's prime factors. Prime factor is a number which has exactly two factors, one in itself. So if we get 525 and get a prime factor at first, the easiest prime factor here is 5. It's pretty straightforward, you can spot that out in here. How many 5s go into, so I can circle that straight away because it's a prime factor. So 5 into 5 is 1, 5 into 25 is 5, so 5 into nothing, that's nothing there, and 5 into 25 is 5. So as we know that 5 times 105 is 525. Again, let's take the 5 out of here, let's take the prime factor out, 5. How many 5s go into 100 is 20, plus this 1 here, so that makes it 21. So let's circle this because it's a prime factor. We don't circle this number because it's not. We can break that down further into its prime factors. Now 21, the obvious number that goes into here that's prime is 3. And how many 3's going to 21 is 7, and 3 is a prime factor, only 1 and 3 goes into it, and 7 is also a prime factor, only 1 and 7 divides exactly into it. So there we go, we got all our prime factors circled. There's nothing else to break down as there's nothing uncircled here, so they've all been circled, so we come to the end of it. So product means to times, so if we times all the numbers together, we'll get 3 times 5 times 5 times 7. If we multiplied all those prime factors together, we will get 525. Now, a neater way to put this is if we put it as 3 times 5 squared, because it's 2 5s multiplied by 7. That's it. This is how simple this question is when you're breaking things down, decomposing it into its prime factors. Okay, let's just quickly clear this and move scroll line further. On to question 9. There's a free marker here. Let's take a second and read this and then see what we can do. Right, we're reading it, best to point out key things. There are 17 men and 26 women in a choir. The choir is, excuse me, I need to clear this message. Okay. One of the men, the choir is going to sing at a concert. One of the men and one of the women are going to be chosen to make a pair to sing the first song. Work out number of different pairs that can be chosen. So straightforward here. You got how many pairs that become chosen. In a pair we got 17 ways of choosing a man, and there are 26 ways of choosing a woman. So work out the total number of different pairs that we can chosen. I'm going to do 17 multiplied by 26, and we can make 442 pairs. Okay, 442 pairs. So got A and B. I'm just here making the decision whether we need to divide this by 2. So let's just have a think. If we had A and B, and there were 3 women, so let's call them C, D, and E. What we can do is there's 2 here, there's 3 here. 2 times 3 is 6. So that means we can make 6 pairings. Let's just make these 6 pairings. We could have A and C, A and D, A and E, or we could have B and C, B and D, B and E. So none of these pairings have been chosen before, so I'm quite happy to say that will be the total number of pairings will be 442. Okay, good. Now, two of the men are to be chosen to make a pair to sing the second song. So 2 of the men chosen to make a pair to sing. So in this one, there was 1 man and 1 woman was chosen. So 2 of the men. Ben thinks the number of pairs that can be chosen is 136. Mark thinks the number of pairs that can be chosen is 272. Who is correct, Ben or Mark? Give your answer. Well, same thing here. So what we could do here, first of all, we got 17 ways of choosing the first man, and then we got 16 ways of choosing the second. However, in here we would be double counting the other way around, so we need to divide this by 2. It has to be divided by 2. Okay, so because if Andrew was paired with Bob, Bob paired with Andrew would be another option, so we need to divide that by 2 so we don't double choose here. So let's look, 17 times 16 gives me 172 divided by 2. The answer to this will be 136, in which case Ben is correct. Okay, so the reason why we divide by 2, so we will get a pairing which is the other way around. Okay, this way the order does not matter, so we divide it by 2. So BA is the same as AB. These pairs are the same, so we double counted in here, so we must share by 2. Okay, so if we clear this, go on to the next one. Question 10. Let's have a look at this. So pairings going on. So let's have a look. So Mary has 25 cards. Each card has a different symbol on it. Mary gives, Marie gives one of the cards to Shelley and one card to Pauline. In how many different ways can Marie do this? Okay, so Marie gives one card to Shelley and one card to Pauline. In how many ways? So, got 25 cards. Okay, so she could give, there's 25 ways of, 25 cards. Okay, so what we could do here is each card different symbol. Different ways this can be done. Okay, so Shelley could get, she's got an option of 25 cards. Okay, and then once those have been given, Pauline has an option of 20 ways of getting a selection of the second card. So yeah, so we would do 25 times 24, which will be 600 ways of doing this. Okay, just needed to double check that she was going to share all the cards, but no, she just needs to give one of the cards to Shelley and one to Pauline, and just want to know different ways that we could do this, in how many different ways. Okay, so let's just slightly scroll down from here. Okay, let's just clear that and scroll it down. Here we go. Second part. There are 12 boys, 10 girls in David's class. David is going to pick 3 different students from his class and write their names in a list in order. The order will be boy, girl, boy, or girl, boy, girl. How many different lists can David write? So look, first of all, he's got 12 options for the first boy, and then 10 options for a girl to be selected, and then boy now there's only 11 options left for a girl. Okay, or means to add. So next one he's going to have 10 ways of selecting the first girl, then 12 ways of selecting a boy, and then 9 girls left to select them. So let's add these up. Multiply them first. We got 1,320 ways of doing this option, and then 10 times 12 times 9, so 1,080 ways of selecting the second option. If we add those together, they will have 2,400 ways of selecting